So just a quick intro to me. I'm Louise Shaw. I'm a partner. I lead the energy and infrastructure M&A team based in London. So we've got a decent sized team, sort of living and breathing the energy transition, really, very much focused on doing deals and facilitating the flows of capital into the sector. So we're pretty active around some of the battery storage pipelines, platforms, and assets, as clearly that's where a lot of the kind of capital flows are in the UK at the moment. So it's my privilege to moderate this session, and we've got a couple of great speakers with very different and complementary perspectives for you. So I will hand straight over to Mark for him to just introduce himself.
Yeah, good morning all. That was a very interesting session, as Louise says. Um, uh, Me and my team and our platform help you actualize your revenues from the batteries that you've seen in your financial modeling, or that's what we try to do, because we are an optimizer, and so we build route to market in all the relevant revenue streams. And it's really interesting hearing the previous call about the um, practicalities of a battery and what it will and won't do, rather than the theory.
Great. Thanks, Mark. And then handing over to Pedro for him to
Hello.
introduce himself.
Thank you, Luis. So my name is Pedro Rodriguez, and I'm the head of Grid in UK and Ireland for Lightsource BP. In Lightsource BP, we are developer of PV and BESS projects, renewable energy in general, but focus on PV and BESS at the moment in UK and Ireland. And my team is particularly involved in projects from early development up to construction, commissioning, and also assisting in operation of projects. Yeah, and that's basically what we do.
Great, thanks, Pedro, and thanks, Mark. Right, so we're going to kick off the discussion, sort of thinking a bit big, and then maybe drill into some of the kind of burning topics that we're seeing in kind of battery storage at the moment. So I guess just starting off with the kind of big picture in terms of particularly, I guess, the conflict in the Middle East and the impact on energy markets, and I guess how that's translating to the current day sort of trading experience, particularly from what Mark's seeing on the optimizer side. But I guess from EY's side, you know, we're kind of supporting lots of businesses around navigating the kind of complexity and uncertainty at the moment. But I think what we're seeing is that, you know, the damage to some of the L&D terminals will probably see longer term impact for gas. Um, and who knows around the kind of straight opening of the Straits of Hormuz and kind of the dynamics around the ceasefire. But I think, you know, as that starts to see impacts later in the summer of storage, of gas storage, will be interesting to see how some of those kind of delayed effects impact, you know, obviously the need and the role that the battery storage can play in navigating some of that. But to the kind of here and now and how you're sort of trading assets at the moment, Mark, how do you see that playing out? Just interested in your perspectives on that.
Well, typically, when we see any sort of energy crisis like we did with the Ukraine invasion, the whole curve moves up, and for a battery that gives greater possibilities because there's a bigger spread of prices to work within a day. But interestingly, this time round, the within day prices haven't really been affected to any great extent. So the sort of spreads we're seeing have varied hugely between sometimes £143 between different parts of the day, sometimes as low just 3 days ago as £38. And so the short-term power market in the UK is being very much driven by its traditional drivers of wind and sun in this country at the moment. And the whole curve in the short end certainly hasn't moved up. So the optimization day looks very similar to what it did before the war. Whether that changes as we move into winter and if the war's still going on, I think that'll be a different kettle of fish because I think then gas will be more prominent in the UK Energy Day or the Power Day, let's put it like that, than it is at the moment.
Yeah, very, very interesting and perhaps not what you might expect. And Pedro, conscious one of the other sort of impacts of that will be around sort of supply chain and some of the kind of inflationary pressures. Are you seeing any of that yet from a grid perspective? Or again, a bit early to see?
Not at the moment in supply chain. We are not seeing specific problems about this. But if things keep on how they're moving, as we experienced in the past, we would expect for sure an increase in the price of the supply chain processes, including transformers, switchgear, and so on. We are seeing, though, not because of the war, but due to the amount of works that are being done in the network, and we are seeing resource constraints all over the place, with long lead items being pushed forward, and equipment that was recently really available to be in longer leads. So that's only because the demand of equipment and resourcing for projects in the network, but also for generation connections, is increasing. So if we add this uncertainty and more supply chain disruptions on the line, we may end up in a worse situation that we are now at the moment.
Yeah, lot of uncertainty ahead. So, I mean, I guess just to pick up on some of that, I mean, obviously we've been going through a period of quite a lot of regulatory change as well in the UK, obviously going through the connection reform process with grid offers sort of finally starting to come through now, but also the kind of wider electricity reform process, obviously not gone down a route of zonal pricing, but pricing reform to kind of come through still. I guess, Mark, what's your kind of reflections on that kind of change, how we've been navigating, and what some of the changes we might be facing over the next few years?
Yeah, well, all the battery owners we talk to are all fretting about the connection reform, and it's really affected some of them, and it's pushed back quite a lot of projects. So, to the general narrative of trying to improve flexibility in the country, that feels like we've taken a bit of a back step. And then there is the child of Rima, if I can call it that, that's recently hit people's emails, which is the reform national pricing and the call for input on that. And that's got some really, really radical steps outlined in it, which are probably, well, not probably, definitely the most significant changes to our market since NETA, if anybody on the call remembers NETA apart from me. And I do urge people who are in this space to have a good look at that, because it contains some significant regulatory threat, also opportunity for flexible assets, but there's going to the grid are looking for some real changes. What's quite interesting is that the initiatives of one part of NESO don't always seem to be joined up with the initiatives of other part of NESO. I know this is going to come as a shock to people on the call, but so I'd say that not everything in the Reform National Pricing paper is consistent or seems to acknowledge some of the other things that are going on in grid reform and other initiatives. But yeah, I think the net takeaway from that is that if you've got contracts, they've got to have really good change of law clauses in them, or which catch this sort of thing, because obviously a battery going on for life of 10 to 15 years, I think our market's going to look very different over the course of the battery lifespan.
Thank you. And what about some of the sort of positive impacts of that pricing reform for batteries?
Well, yeah, there are for a battery some positives. So, for example, if settlement periods get reduced from half hours to 15 minutes or 5 minutes, I think the flexibility is going to become a lot more important as people try to manage their positions. I think the requirement for gate closure to move, they're going to roll back. I think it's P462. I'm really bad on my numbers, but I think it's P462. So that gate closure and the trading gate are aligned again. At the moment, there's about a 45-minute difference, which allows people to change their traded position in that 45 minutes from their FPNs. I think that will also bring those two together will also be an opportunity for batteries. Whether the obligation to put every asset down to 1 megawatt into the balancing mechanism helps or hinders batteries remains to be seen. As we know, batteries have suffered from skip rates over time, and it might be superficially appealing for everything to be in the BM, but if you get skipped, you might choose to stay in the traded market rather than the balancing mechanism.
Thank you. And Pedro, just interested in your sort of reflections around the kind of regulatory backdrop, and I guess particularly sort of connection reform.
Yeah. So adding on to Mark's point of view, in the balancing mechanism obligation to participate from the 1 megawatt threshold, I do agree that I have two conflicting visions there. So first is that as a developer, it incurred additional costs, capex and operational costs for smaller projects mostly. But then from an engineering perspective, I'm being engineering myself, I think it's a good point from the system operator to have more visibility and actions for all the assets in the network, or assets that have some strength. So I think that's a positive movement from NES on that part. In regards to connection reform, now there's been a call for input again for the changes in the methodologies for the next window. So there's a call for input now, and some of the key points that probably affects lots of developers are demand style of the methodologies, but also how every projects are treated, and particularly collocated. There's mention about being prioritized if you are collocating at best for the next gated windows against that prospect. And considering the big queue of best projects that are at the moment, that's quite of a complicated situation to be. At the moment, in export-only batteries may be not financially viable. So there's a lot of ground, and as Mark says, there's lots of uncertainty.
There's an interesting aspect, and I think you're absolutely right about the transparency, Pedro. That's what they're after. What's really interesting now about the fact that the grid is wanting to get better visibility of smaller assets is going to need to be far better coordination between DNO/DSOs and the grid, which we've been talking about for all the time I've been in flexibility, 8 years without not much happening, and the two groups seeming to work independently. If they want to make some of these changes that they're talking about in the RMP, then there will have to be much better coordination. And as we know, some of the DNOs are quite advanced in the way they think about flexibility and flexibility markets, and some of them are still sort of stuck in the 20th century. So that's going to be really interesting to see how that dynamic changes.
I won't ask you to call any out on that.
Yeah, I completely agree with Mark. But also there's something very interesting there is lots of distribution projects connecting now are under non-firm connections, subject to A&M, intertrips, and so on. How those arrangements coordinate with the visibility of the balancing mechanism? That's a complex one.
Yeah, I'm not sure we've got time on this webinar to fully resolve that, but we'll see. I I think we maybe move on to another sort of regulatory topic around the kind of LDES cap and floor regime that's obviously kind of being bid at the moment. I'm just waiting for the outcomes. I think yeah, it'd be interesting to kind of hear views on how the kind of longer duration 8-hour systems with a cap and floor mechanism might sort of impact on the wider sort of energy market, and some of the existing battery storage assets that we've got in the grid. So Pedro, do you want to kick off on that one?
Yeah. We have been investigating the cap and floor arrangement. Obviously, I'm not an expert on that, but I see it as an incentive, a financial tool to provide certainty to a arrangement or some kind of technologies that are not as streamlined as others. So in terms of cap and floor and longer duration, I can see that probably the technologies on the market are going to go into more duration in the next windows. So I will shift to Mark on this one. I think he would probably have a better opinion on the cap and floor scheme and the financial implications of that. Mark?
Yeah, thank you. Right. Personal opinion is, which I'm going to get out there first, so that you see where my prejudice is. I hate cap and floor. As the trader in me hates it, and it's been deployed in the UK market and it's had an effect on liquidity because all the suppliers and generations gets concentrated into the front end of the curve, which is distorting. Let's look at some facts around the cap and floor with restated LDES. One, we know that Zenobia still got a challenge out there, legal challenge against the scheme, because they think it is distorts the market, and we're waiting the outcome of that. I'll let you decide whether you think it distorts the market. 70% of the projects that have passed through for the cap and floor are lithium ion, and that means that those long duration lithium ion batteries can compete in the short market just as well as the existing fleet of batteries, which means they're going to have an economic advantage, and risk leaving some of the existing fleet stranded assets because they're being underbid by subsidized assets. And I can't imagine that hasn't been thought about, but it's interesting to see that so much has been given to the lithium ion fleet. If you look at spreads in the market, the shorter assets make better spreads than the longer duration assets, and that's a function of how the electricity day is developing, as we see less spikiness about in the market in the traditional within day duck shape to the prices, and we start to see prices flattening off and just a few peaks. And then the third aspect, which I don't think should be ignored, is NESO is really good at saying when it needs something, and it's deployed a number of services to meet its grid operational needs. And in recent years, we've seen the 3 frequency response contracts rolled out. We've seen slow reserve, we've seen quick reserve. But what we haven't seen is NESO saying, hey, we've got a long duration product because that's what we really need to look at. And the fact that NESO is not putting out a service that specifically looks for a long duration need, I think tells us a lot about what's viable in the current system. So it's no wonder that long duration is looking for a subsidy, because there aren't any obvious revenue streams that feed into it.
Yeah, no, it's an interesting dynamic, isn't it? And I guess the sort of, the argument is that actually that call it subsidy is needed in the energy market to provide that kind of long duration, backup to the system at times in which it's needed. And I guess, NESO knows the cap and floor, auction process is in process, but based on what you see, you don't think there's a need for that.
Well, if the strategic narrative is that we're going to have long periods when there's not much renewables and we need some backup because fossil plants gone off the system, then some sort of reform capacity market might better serve the needs of that. But again, as I say, I do think cap and floor is market distorting. And you can see that in the way that the NESO is being gamed at the moment. And the fact that wind, when it knows there's going to be a lot of wind around and potential for negative prices, does not play in the day ahead market. It leaves itself and trades in the within day market where it won't have to pay back on its cap and floor scheme. So that is market distortion in itself, just the way the wind behaves at the moment. And I just don't think it's been thought about properly. But as I say, it's a personal opinion. I'm not alone in thinking that, but I don't think it's what our market needs.
Very interesting, and always good to have a range of views on these topics. So perhaps we sort of stay with the duration point. I mean, based on what we're seeing in projects, particularly for sort of 28, 29 connection dates, increasingly developers or IPPs thinking about building out sort of 4-hour duration storage assets. I mean, what's your take on this? I guess go to you, Mark, first. Around the kind of 2-hour versus 4-hour systems in the current market and how that picture might evolve.
I think you do better in the existing capacity market with a 4-hour battery than a 2-hour battery because it doesn't get derated so much. The capacity market is a nice piece of your income. I think if we look at the way that 2-hour batteries came in after the initial fleet of 1-hour batteries, the 1-hour batteries sort of slightly painted themselves into a corner revenue-wise. They were really good at doing dynamic containment, but less good at being able to exploit some of the other revenue streams, and sometimes would find themselves needing to recharge at times, which they probably wouldn't have done if they'd had the choice. So the 2-hour and the 2-hour plus seem to be the sweet spot. And we see quite a lot of now 2.4-hour, 2.5-hour systems. I think it has to come down to, you can only look at the market that we've got at the moment if you're a battery owner, and therefore I'd urge people to do their sums properly to make sure that the extra that you're paying for more capacity is matched by where you think you'll make your money. And that does require some quite granular revenue forecasting by people who really understand within day market dynamics, and rather than some of the more generic consultancy approach financial modeling, which while they may be bankable, might not be particularly based in reality.
Yeah, that eternal debate of the forecast. But as you say, I mean, it is very sort of project and location specific, isn't it, around those dynamics and getting into the granularity of those forecasts, how penalties might play through. There's a lot of detail to that, isn't there? Pedro, just come to you with thoughts on the dynamics around durations.
So the dynamics for long duration, from the grid perspective, I don't, in terms of connecting these technologies per se into the grid, there's not too much difference of the hours that you have behind the inverters of the capacity. So that's not a major change. What may change is about the balancing mechanism and the impact of long duration onto the balancing mechanism per se. So lots of the problems or the increases in the cost of curtailment in the network that is one of the drivers that NESO is trying to push down, because they are estimated that 8 billion costs may come around 2030 if things don't change due to balancing mechanisms alone, the prices they need to pay. Long duration may mean that some flexibility is added onto the wind farms output on the north to the south, which is where the main constraints are in the network. So that could help marginally that bit of curtailment. But we need to bear in mind that there's no magic solution, and adding more batteries and flexibility in the network gives more complexity on how the network is operated in the end. And I don't think that it is clearly pictured that adding much more distributed flexibility in the network plus real-time information adds more complexity in the control rooms of NESO to do the balancing mechanism. So in the end, what I meant to say is, I think that balancing the long duration may improve things, but up to a certain extent. But that's always good for the balancing mechanism cost reduction.
It will be good for the balancing mechanism if there is some reform of the balancing mechanism, which they're talking about, because at the moment, batteries are really, really good at exploiting those constraints. They set themselves to export in the day-ahead market, sitting behind a constraint, and then they get bid off in the balancing mechanism. And they'll keep on doing that until the constraint disappears. So the only way really to stop that cost, which we're all suffering in the balancing mechanism, is to change the rules such that, this is just an idea, that if you set yourself to export and you're behind a constraint, when you get bid off, you don't get paid to bid off. And that would probably nip that little game in the bud.
Hopefully NESO's listening.
Well, they know. I mean, they know they're being gamed.
Yeah. Yeah, I mean, any other reflections on sort of how, I guess, the evolving, pricing dynamic of sort of shorter settlement periods might interact with longer duration batteries?
Mark, do you want to take it on this? Because yeah, I'm not, and I don't have a clear opinion on that, to be honest.
To be honest, I haven't really thought it through, and I don't want to give a sort of shoot from the hip answer, because I think the question's a good one, and it will change the way batteries work, but it may mean that with shorter settlement periods, renewables have less need to park some of their generation, because they can be more granular about how they match up with system needs. I don't know. I think it needs more thought, and I think actually, just to that, there's probably not enough cost benefit analysis yet that's evident from reform national pricing that's been made public. There's probably somewhere, but it's not been made public. And I think these aspects of the system really need to be thought through, because if we do change all these things, the data flows are going to be massive compared to where they are now, between Elexon and generators and so on. So I think more economic analysis needs to be done on this, and I haven't done it.
Yeah. It goes back to that point about engagement around the consultations and, working together as industry to kind of think through some of these dynamics to make sure it does flow through into the policy decisions. I think we'll move on now to kind of think about some of the impacts around the kind of grid dynamics. Now, clearly we've touched on kind of connection reform earlier, but clearly huge volumes of both battery storage and renewables coming online over the next few years, hugely ambitious targets under that connection reform process. But I guess there's an element of sort of disconnect between what's happening at NESO and what's going on the ground with the DNOs and transmission operators. What's your view? I guess, Pedro, come to you first.
Yep.
How do you see that dynamic sort of impacting the build out of renewables and battery storage, I guess, at the moment and over the next few years?
Yeah. So at the moment, what I see over the place, and this is not only particularly in the UK, but lots of other countries as well, is that the network is clogged, and there's huge amounts of issues about connecting on time and the outages that need to happen in the network, along with resourcing. So just to give a little bit of picture, I'm not sure if you're aware, but NESO published a letter to Ofgem indicating that they expect 62% of protected projects, Gate 2 protected projects, not to connect on time. And that clearly gives a message of how the system, how congested the system is. That means that lots of the infrastructure needed to be done time ago, even lots of years ago, starting with the connect and manage scheme in 2010, has not been deployed. So one of the things that has happened is that the generation and the technology of renewable energy has been faster than the deployment of infrastructure all over the place. And now it's getting to a situation where nothing or barely anything can be connected to the network on time that was promised some time ago. And that's also adding to the situation that NESO is developing infrastructure at the same time that connections are trying to connect, and that's creating a backlog of outages to connect these projects, and that's adding up. So there's a real struggle of certainty about connections when things can get relatively connected, and also that is backlogging on or feeding back into the balancing mechanism and the constraints in the network that the ultimate creates the situation of the fees that needs to be paid to the balancing mechanism in general.
I've got. Can I just
I was going to
ask
come
a
to you,
quick
yeah.
question? Well, I just wanted to ask a question of that because, given what Pedro has been saying, it seems what we're hearing anecdotally is that some people are sort of saying, "Hey, I can't get DNO connected. I'm going to get connected at a transmission level," and we're seeing a few more transmission level battery projects coming on than we'd seen before. But I'm not an engineer, and I don't understand necessarily the implications of connecting at that level compared to the DNO. I wondered if Pedro got thoughts on that.
Yeah, so you normally choose connecting in the DNO and TSO level, depending on the amount of power you want to deliver, because the economics of scale matters. So you normally, at transmission 275, 400, you will be talking about more than 100 megawatts projects. In terms of when you can connect, probably is that the transmission network is saturated at the moment. So you will need to not only connect physically, you also to the substation or the TSO, for example, or the DNO, but you also have to be enabled to connect due to the reinforcements of the network. So the network needs to hold your connection as well. That's why firm and non-firm connections come into place. Lots of the new connections that you can see in the market now have non-firm connections because you are connecting ahead of the enabling works that makes your connection firm. But that even has a limitation because there are physical outages that are required in the substations and in the network itself to connect yourself physically to the network. So there's a situation that there's things that need to happen before you connect, but also other agents are competing for the same rights to connect and to have an outage for themselves. And that's creating a clock. And that's time, essentially. So we are seeing things delayed.
Yeah, and I think then very difficult to navigate those kind of delays, certainly through transaction processes that we're seeing, how you can, manage investment decisions around, uncertain timing backdrops is quite difficult to navigate at the moment, isn't it?
Well, the other is a real organizational element to this, because obviously developers are paying teams of engineers and everything that goes with the development, and that's they're just sitting there on our hands, but still needing to get paid, and so it has a real sort of economic impact.
Yeah, definitely. And a lot of, the comments Trevor was making earlier around, the teams and the kind of breadth of skill sets that's needed against that, and, managing the planning dynamics as well, and planning conditions, and some of those other sort of development and construction timelines and supply chain. It all kind of goes through to that timeline point, doesn't it? Rather than just, grid connection is 28 versus 29 or whatever the dynamics is.
And there's also an add-on to this is what we are seeing also is that NESO and TSOs in general and DNOs are expecting the developers to make final investment decisions with a higher degree of uncertainty. And it's very difficult to go to a board for a final investment decision and saying that the connection date is not guaranteed, or your costs are not guaranteed, or you may face a curtailment event that you cannot put your hand on. So the uncertainty is increasing in general.
Yeah, very difficult to navigate. And just want to pick up again, Pedro, on the point around non-firm connections, and I guess how we can sort of navigate particularly the sort of economics of those non-firm connections. We're obviously seeing kind of more and more of those solutions coming through.
Yeah, so non-firm connections, basically, the origin of non-firm connections comes because, or the source of it is that you are being connected before certain enablers in the network are deployed. So you are connected ahead of time, let's say. In each country is different, and it can vary greatly. In the UK, normally, at distribution level, you would have an interest rate or a A&M scheme, which is a little bit more simple than transmission, and there's a relatively high degree of certainty you can make on estimations, because the variables that input on that potential curtailment, technical curtailment, are relatively enclosed in most of the cases, not all. In transmission is instead another story. You may get simple variables that you can add into a model and make an estimate, or if you have a curtailment that involves into a mesh network, then it's very difficult to estimate. And you have to consider that it starts to be really complicated, because sometimes your curtailment depends on overloads on overhead lines or in assets, and those assets are related to how the market works on batteries, how the market behaves, how the PV farms behave, and how the demand behaves. And now you're adding data centers, you are adding longer storage. Things change a lot. So this uncertainty is great.
Yeah, and Mark, have you been trading any assets with non-firm connections? How do you see that playing out from a trading perspective?
We haven't, because I mean, Pedro's given some inklings about how you'd model it, but we've just generally felt that when non-firm connections just makes the economics of a battery so uncertain that we haven't got involved in them.
Interesting, quite telling in its own right. And I think, will be some quite interesting decisions, particularly as we're seeing, whether you can build an asset or not. The sort of, the promise of a non-firm connection makes a lot of sense to the, dynamics we were talking about earlier.
Well, if you extrapolate it into this sort of commercial space, when somebody comes along and says, we're bringing a battery to market and we want it to have a floor, for example, and for us to grant a floor, we have to do a detailed revenue estimate to work out what we think the battery's going to do, and then derive the floor from that. But if we can't do a detailed revenue estimation, that makes it really tricky to provide a floor with any sort of confidence.
Interesting. So yeah, we'll have a very real impact on sort of routes to market and what contracts are available for those assets. Maybe if we move on to talk about co-location assets. I mean, clearly, sort of on the face of it, an interesting way of utilising sort of scarce grid connection capacity. But I think, I mean, in particular, we're seeing quite a lot of dynamics between co-location assets having different grid offers, one phase one, one phase two, one gate one, gate two. And again, that's been sort of quite difficult to navigate some of those dynamics from a sort of practical perspective. But just interested in Mark, come to you first. Just thoughts around co-location, sort of how you see trading those assets versus standalone. You know, how what will their role be going forward?
Well, assuming that the export is something that properly needs to be shared, and we're working with a co-located asset, which is it's comfortable for both the wind and the battery to get out through the export without either of them bothering each other. So they basically act as standalones. And Pedro might talk about DC versus AC connected, which we thought we might touch on. But in an AC situation, we'll normally find out from the asset owner what they need to take preference in terms of if the generation asset's got a subsidy, it very often gets preference through the export before the battery comes in. So you then got to do the modelling to take the likely export profile and then have the battery work around it. So in some ways, that's almost like a constraint in itself in what you're going to produce as a in real action and B in a revenue estimate. But it's actually, I think, co-location makes a lot of sense. And if you can make the numbers stack up and you can get the right proportion of battery megawatts to generation megawatts, I think it's a really good solution. And we quite enjoy working on co-located site proposals, propositions. I would say there's a lot to think about in terms of metering dispensations, site layout, MPANs, separating out, what assets done what. All those things need to be thought about in a lot of detail. But generally speaking, I think it makes sense. It normally makes sense more for solar and battery than wind and battery for obvious reasons. But yeah, we like it.
I mean, it's interesting the sort of that the complexity of those co-location projects, and I think a lot of the kind of optimizers that we've spoken to sort of maybe have separate teams that look at the solar versus the BESS and thinking about it, sort of from a BESS perspective and then a solar perspective, rather than how do you sort of integrate that proposition from a contracting perspective. I don't know how you're thinking about that.
Sorry, I started to think about the financing aspects, because you very often find with the site that your financier's got one department that's financed the generating asset, another department's financed the battery, and they both want to get paid out and have revenue certainty, which is probably unhelpful for the site. Ideally, if you can get the same department looking after the financing whole site, you're in a much better space. Do you mind repeating your question?
Yeah, just from a trading perspective, because I think that they tend to be quite sort of separate teams, trading batteries versus solar, and then offer one contract on the battery and one contract on the solar versus thinking about it as an integrated co-location system, even for AC coupling, and just interested in how you think about that.
Well, typically, I think the two don't really cross over too much. You get a PPA for the generation asset, and assuming it's got preference, that will just generate and get paid out as you'd expect. And of course, PPAs are non-firm anyway, so you always say you'll pay for what you get, pretty much. And the where it can become quite interesting is PPAs have evolved into a space now where, especially when there's a corporate on the other side, they're interested in time-matched generation. Now, once you start running the power through the battery, because it makes sense from a market point of view to not export but charge the battery, all of a sudden you've got the generation actually disappearing at a different time of the day. And I think that's where it can get really complicated. And this is a relatively recent phenomenon. When it's just a PPA generating, it's not a big deal. The generator does its stuff and you've got your optimization contract. And if the optimization contract has got to acknowledge the superiority of the generation asset, it does so. And it just reflects itself in the revenue estimate.
Great, thank you. Pedro, maybe come to you and thoughts on co-location, if you can pick up on the kind of AC versus DC coupling point as well.
Yeah, so I will start a little bit following Mark's remarks about co-location in general and how these two integrates. Essentially, from a greater perspective, one of the challenges that we're seeing as well with co-located projects is first what you mentioned, Louise, about projects with PV solar farms or wind farms with gate 2 and then BESS having gate 1. That adds uncertainty on how you can collocate projects in the future. One of the upsides is the green infrastructure sharing. So you share grid costs with the both assets. So collocation makes a lot of sense. And there's lots of uncertainty about what you can do with collocation with projects that you have with gate 2 and BESS. And if you are only restricted to export and not import from the grid for the battery. Then there's another thing which involves the AC coupling, which is at DNO level, there's ways to separate both the PV and BESS and make them both separate entities without clashing with the Electricity Act 1989. But in transmission, that's not clear. There's some challenges there on how you can separate both assets and make them independent, because under the Electricity Act, if you operate as SPV just with transmission assets, you are conveying electricity from one point to the other, and you need a license to do that. So there's a gap, regulatory gap there on how you could make collocation effectively with a transmission asset. And that's something that probably is going to be discussed with the inclusion of the ITSOs and some other aspects and regulatory aspects. But at the moment, it's unclear on how you would do that. Then on ACDC, I think the preference, even though the optimization may be better in DC coupled, the preference so far has been AC coupled. So you can separate projects and maintain them separate at different levels. Also, it helps that BESS are contract solutions more than often, and you can segregate things, which make things more simpler. But this conversation AC/DC coupled comes back every 6 months. So I don't know, Mark, if you have any thought about DC coupled in particular from trading perspective.
We've looked at one, and from a trading perspective, it's really interesting because actually you're optimizing the whole site rather than letting them do their own thing. But so far we haven't found someone who's actually decided to go down their route. We've done the modeling for them, but I think they're still sort of thinking about whether it makes sense, probably for some of the reasons you've outlined. And of course, you're dependent on one inverter, aren't you? And we've seen what can happen when you lose an inverter, because it's not something you're going to keep in your stock of crucial stocks. It's something you're going to have to order, and there's a good time lag on getting one back.
yeah, it comes full circle to those sort of supply chain constraints, doesn't it? And, yeah. And long lead items. Yeah, interesting dynamics there. I was going to pick up on data centers and the impact, I guess, on the grid of those coming online. I guess again, sort of pros and cons. And I see there's a question in the Q&A around AI, which maybe we'll pick up after that. Pedro, welcome your thoughts initially.
So this data center deployment, and it's interesting. I've been hearing lots of things happening in Ireland about data centers and the cloud that they're creating as well, and it's something probably similar everywhere else. The network reinforcement plan by the system operator and the government agencies in different countries were planned to enable renewable generation and an expectation of demand at that time, but now that demand is changing a lot. So the reinforcements are now planned today and being worked out today are not having in mind the data center deployment that are asking to connect today as well. So there's like a miscoordination, but it's due to the speed of things that is happening at the moment. So it's a very interesting topic because I've been also reviewing that data centers can be flexible and they can work in a flexible way under certain circumstances. So it will be an interesting topic about how data centers could add flexibility to the network without being an absolute clog and additional trouble down the line in the network infrastructure.
Yeah, come back to some of the kind of grid planning points that were discussed earlier. I don't know, Mark, have you got any thoughts on that?
It was interesting that Luke Sperrin at the beginning said he was in West London and there's a lot of data center activity out there in the West. And that we talk about data centers as though they're one entity, but as we were just sort of saying, there's going to be some data centers which are providing high latency for AI, which needs high latency, and there's probably going to be others which you don't need that, and therefore you don't need that sort of adjacency, proximity. I mean, like those West London ones. But, I saw a really interesting slide from somebody on when we were talking about data centers and power energy demand recently. It said in which I don't know if it's true, but one Ronaldo Instagram post used up 92 megawatt hours of energy. And I thought, if we're using so much energy just for the less crucial aspects of AI, or not AI, just data, what are we going to do when we actually start really needing it for? And we've seen AI in the last 12 months, as we know, has absolutely gone through the roof. We're now also contemplating all the massively increased data flows we're going to need for reform national pricing. We also know that from the generation queue, that a lot of generation isn't getting onto the system. So there seems to be a real mismatch between the demand we're going to need and the generation we're going to have. And it just seems that if just on the basic laws of demand and supply, that seems to say, well, energy prices can only go one way. Now, I'm sure it's not that simple, but I'd really like to see how much data centers can be flexible, but I don't sense for a lot of the sort of stuff that we need data for that, I know it might be just lacking in imagination, but I don't see how much flexibility we can get out of data centers. And maybe we need to have different types of data centers, as I said, due to latency reasons.
Yeah, exactly. I think data centers is a sort of catch-all terms, isn't it, for lots of different types of data centers and different requirements for different types of AI processing versus hyperscalers, etc. So yeah, there's sort of a bit of a complicated picture, I think, sitting behind that.
Yeah, and who follows Ronaldo these days anyway?
Exactly. Yeah, we all need to do our bit and unfollow him, I think. I guess, yeah, just picks up on sort of Ben's question online, which I think is perhaps a bit more sort of touching on how AI can be impacting sort of infrastructure planning. I mean, you've touched on, Mark, the dynamics around sort of shorter settlement periods and the sheer volume of data there. But yeah, the question just asking around planning, operation, or pricing, and some of the kind of opportunities that AI might bring there. How are you thinking about that?
You asking me or Pedro?
Sorry, Mark, if you go first.
Well, I know one thing. I wish I'd asked AI about the Reform National Pricing 133-page document before reading it, because it did what I took a week to do in about a minute.
It's very good at things like that, isn't
Yeah,
it?
but you just don't know, unless you've done it, you don't know if it's going to do a good job. So it's
Mm,
sort of chicken and egg thing. But I mean, in our world, never mind all the that. I mean, we use the cloud a lot because our platform's all about data and being able to extract data quickly and make decisions in our optimization. We use the cloud. Um, we use a lot of machine learning um, rather than AI decision making. We wouldn't go that far, but I think I suspect we're not untypical, and um, in order to, and I imagine the grid must be sort of really thinking, NISO in their control room must be really working out how they can use this to their best advantage. So for me, it's only going one way in the energy world, and that we will see we'll see increasing uses of it. You know, we do a lot of coding for our platform, and there are certain parts of our coding which we can get AI to do. Some actually much more needs to be um, human, but AI can really help with some sort of the bog standard stuff.
Yeah, no, super interesting. Every time I think about it, it blows my mind slightly. But Pedro, how are you thinking about AI?
Yeah, I agree with Mark, and he mentioned something I do agree with is in power systems and all the information that NESO needs to process. There is room for AI intervention. Particularly, I'm thinking about modeling all the system modeling, so all the generators that have not been carefully incorporated. So there's lots of work for NESO to actually set up a model of a system that works and can be reliable. And there's lots of information there. So using AI to streamline that would be, I think, probably they are on that at the moment. But there's something that I'm aware about AI, and is about the power system is a non-linear system, so it's complex per se, and it follows certain rules that are not evident and not straightforward. So in power system management, when you are in taking fast decisions in a complex environment, you want simplicity. So I think AI can help a lot in its own frame, but also simplicity in a complex world and a complex network that is going to be more complex day by day. I think is paramount. Um, because if the things go out of control, then maybe be situations that may happen. So yeah, there's a confront for me about simplicity and how simple things are easy to control. But in the rest of the aspects, I think is a win, to be honest.
Yeah, very interesting. Jordan, how are we doing for time? I think that was.
I think you are pretty much out of time, but I was so interested in the conversation that I didn't want to like interrupt or anything. Please, if you've got a little bit more, then continue. You're the last session of the day, so we can go a bit longer if needs be.
Great. I think the only other topic I thought might be worth picking up on is just around sort of negative pricing. Obviously, we're seeing, big problems in Iberia. how that impacts around, PPA, CFDs, and kind of, I guess, opportunity for battery storage. I think, the UK market is slightly different in terms of the kind of balance between wind and solar and the development of battery storage. But I just wonder, Pedro, any perspectives from you on that, and then Mark, maybe come to you.
So in regards to negative pricing, I'm aware that in Spain is a problem. So probably as batteries thrive on volatility and spread, there's a big opportunity for batteries to make money out of it. Apart from that, I don't have a clear picture or clear opinion of how the direction of this will be. So I'm not sure if the negative pricing will keep on getting worse due to more renewable energy being implemented in Spain or in the UK. It gets more complicated, or if this will be sorted out due to the amount of batteries benefiting from the spreads and operating in this particular market. So probably Mark has a better picture or opinion on this.
Yeah, well, I mean, get rid of subsidies and we get no negative prices. That's a statement of the obvious. But the narrative is that negative prices are great for batteries. But as I was just looking at some numbers before this session. In the UK on the 4th of April, which I think was a weekend, out of the 24 hours in the morning auction, 17 of them were negatively priced. Yet that was by a long way from being the biggest day for price spreads in the last month. So negative prices don't necessarily mean batteries are going to do better than they will do on a positively priced day, actually. But they are created a lot by assets just juggling themselves between within day and day ahead. They are created by assets sort of trying to dodge around the CFD, and they are a market distortion essentially, and I suspect that the regulators really need to think about, and I think they've started to think about it with the CFD, but really, regulators really got to think about how to create a market that won't produce negative prices. And as I say, the simplest way is to remove the subsidy in certain circumstances. But I mean, that's just a non-flyer. Yeah, I mean, there's not much more I can say about it, actually.
Yeah, but I think raises some really interesting questions, doesn't it, for how we move forward, potentially future CFD rounds, and how that plays through as we get more and more solar and wind on the grid. Okay. I think that was all the topics that I had on my list. I don't know, Jordan, if you had any other questions, but
I think you answered the one question that we got from the Q&A. And that was actually really jam-packed, full of so much information that I was just sitting here trying to absorb it all. The interesting thing I really found, especially, was when you spoke about data centers, because that's becoming more and more part of the conversation, the energy conversation. And I can put on my electrical review editor hat, but also I'm also editor of Data Center Review, so I get to see the two sides of the story. And obviously, data centers will argue that they're trying to be good citizens when it comes to the grid, and I know there are solutions out there that. So Ireland's a really good example that obviously they've had a lot of grid constraints around data centers, so much so that they put a moratorium. I never quite good at saying that word on building data centers in the country. So they came up with a new scheme where basically data centers had to match their power with what they're taking from the grid, so they can produce it through backup power. They could so that if the grid needed them to, come offline for a bit because the grid's a bit constrained, data centers could then go and produce their own power, or have a grid that they could completely detach from the grid. That's a solution that they found in Ireland, and maybe could become a solution further in the UK. But
I think
Mark,
that's one of the problems with data centers is that because they're so huge, it's not like they're distributed. They're bigger than a lot of power stations, and therefore they can have a. So while the Irish solution is really interesting, and makes total sense because data centers can have a disproportionate effect on the grid just because of their sheer size.
Yeah, I think the other thing the industry are really concerned about at the moment is the conversation that the public is having, thinking that data centers are going to have, X amount of impact on the UK electricity system, or the grid in general. And yet a lot of what's speculated in terms of data centers isn't necessarily what's going to be built. So I think that market needs to be more sure of what it's going to be building before it gets to the point that we start panicking and running around like headless chickens, not knowing what's coming down the line. I think there's a lot of doom and gloom in all of these markets at the moment, and we just need someone to sit back and take a chill pill almost.
Well, I think there's an aspect of data centers a lot of people haven't thought about yet organizationally. Um, we've all Most of our organizations at some stage or other have done carbon footprinting, but I'm wondering if there isn't a case for data center footprinting as well, because if you're unnecessarily using a lot of AI, you're unnecessarily using a lot of data center and all the environmental impacts of that. Something we should be thinking about in the same way we think about carbon footprint.
Yeah, absolutely. There's a lot. I think we're still in the early stages of, well, obviously data centers have been around a long time, but we're still in the early stages of fully understanding what AI is going to have in terms of an impact going forward. And I definitely think, yes, you are right there. We probably need to measure how much of an impact it's going to have, and what we're using. And your point earlier in terms of, a pointless Instagram post from Ronaldo, why is it using so much energy?
Currently, even using polite words like please and thank you with AI has a massive impact on data center use, which is why you shouldn't be quite so polite when using using it.
Absolutely. All right. Well, I think we've taken enough of your time. Really do appreciate that really insightful conversation. Thank you for joining us, Louise, Pedro, and Mark. Thank you.
Yeah, thank you.
Yep.
Thank you.